Let's sketch the graph of the rational function f of x equals 3x minus 12 over x plus 2. In order to do this, let's look at a few characteristics of the graph that we can identify from the formula for the function. First, we can consider symmetry, whether the function is even or odd, and by looking at the two polynomials, the numerator and the denominator, we can notice that neither of those are even or odd, and so there is no symmetry for this particular function. Next, let's think about the y-intercept. For the y-intercept, I want to plug in 0 for x, and when we do that, we get simply negative 12 over 2. So the y-intercept is going to happen when y equals 6. So the point 0 comma negative 6. For the x-intercept, another important point on the graph, for the x-intercept I want to solve the equation f of x equals 0, and for rational functions that's going to happen whenever the numerator equals 0. Because to solve this equation, the first thing I'd like to do is multiply both sides by the denominator to cancel it out on the left hand side, but 0 times x plus 2 is still just going to be 0. So we end up with a simpler form of the equation of 3x minus 12 equals 0. But of course that gives us 3x equals 12, so x equals 4. So there's only one y-intercept at 4, 0. So that's some nice information. Because we're dealing with a rational function, we might want to consider asymptotes. So vertical asymptotes are going to happen when the denominator equals 0. So x plus 2 equals 0 when x equals negative 2. And to just double check that for a moment, negative 2 does not make the top equal to 0. That happens when x equals 4. So this will be a vertical asymptote. For horizontal asymptotes, we should consider the degree of the numerator and the denominator. That's the easiest way to kind of think about this. Because they have the same degree, then the ratio of the lead coefficients is going to be the horizontal asymptote. So 3 over 1, taking the lead coefficient of 3x, the coefficient of 3x, and the coefficient of just the x term in the denominator. So there's a horizontal asymptote of y equals 3. So let's start making a sketch to kind of see what we have so far. What our graph is going to look like, we have a y-intercept down at negative 6, and an x-intercept at positive 4, and we have a vertical asymptote at negative 2. And then there's a horizontal asymptote at positive 3. So to just be extra careful, let's plot a few more points to find some other kind of key points on the graph. For one, let's start by looking at points to the left of the vertical asymptote. So I can maybe plug in something like negative 4 for x. And if you think about what happens with that, we end up with negative 24 over negative 2. So that's going to be a positive 12. And if I plug in negative 10 for x, I end up with negative 42 over 8. And so that'll be roughly positive 5 something, like 5.25. And then for the positive side, let's imagine what happens if we plug in something a little bit farther to the right, like 10. If I plug in 10, I end up with positive 18 over 12, so that'll be positive 1.5. So you're kind of thinking about those points, maybe adding them to our list. Positive 10 is going to be over here at 1.5. Negative 4 gives us a value of positive 12. Negative 10 gives us a value down at a little above 5. So using those extra points, we can feel a bit more confident about the general shape of the graph. Seems like we're going to drop down along the vertical asymptote as we approach it from the right, and then sort of climb up and stay probably below the horizontal asymptote. And then on the other side, we'll be above the horizontal asymptote and climb up along the vertical asymptote as we approach it from the left. We could plot a few extra points to see, and feel, even more confident about that. Maybe one more good point to see would be -1. If we plug in -1, we get -15. So -15 is the value for y. So that agrees with where we think the graph should go. And likewise, if we plugged in -20, we would get a -72 over 18, which would give us a value of +4, which agrees with where we would expect the graph to go on this side. So that's the graph of our function. It has one vertical asymptote, one horizontal asymptote, a y-intercept, an x-intercept, and then plotting a few extra points helps us figure out the general shape around those asymptotes. I hope you enjoyed the video. Thanks for watching.